Hello and welcome to Lucid Mind. This is Majid and today I'll be solving Chemistry A-Levels Multiple Choice Paper 11 from October-November 2020. You can go to any particular question by following timestamps given in the video description. Let's start.
Question number 1. Which statement is correct? A. Chlorine has a relative isotopic mass of 35.5. Now we know that in the periodic table isotopic mass is not given, but instead the average atomic masses are given. There are two different isotopes of chlorine. One is having isotopic mass 35. Second is having isotopic mass equals to 37. So this statement is incorrect. B. Chlorine has a relative molecular mass of 70. Now, according to the periodic table, the atomic mass of one chlorine atom is equal to 35.5, and as this is Cl2, so 35.5 into 2 will be equal to 71. So this is also incorrect. C. ICl has a relative molecular mass of 162.4. Let's calculate the molecular mass. For iodine, we have atomic mass equals to 126.9. For chlorine, we have 35.5. Summing them up, we get 162.4. So C seems to be correct option. D. Sodium chloride has a relative molecular mass of 58.5. Now we can find the mass of sodium chloride, but that will not be relative molecular mass. Instead, it will be formula mass. This is because sodium chloride is an ionic compound. So in ionic compound there are ions present, and we always calculate the formula mass of ionic compound. For sodium chloride, the formula mass will be equal to 58.5. So D is also wrong. The correct option is therefore C. Question 2. Strontium metal can be extracted from strontium oxide SRO by reduction with aluminum. One of the possible reactions is shown. This is the chemical reaction which is balanced. What is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium oxide using this reaction? Two things are given in the question. One is strontium oxide and second is strontium. We can find the ratio between them. So we have SRO and SR. The number of moles given in the balanced equation is 6:3. In the question they have given 100 grams. Let's first change this into moles. So moles is equal to mass divided by molecular mass. Mass is 100. Molecular mass of strontium oxide will be equal to 87.6 for strontium and 16 for oxygen. So it comes equal to 103.6. So moles will be equal to 100 divided by 103.6, and it comes equal to 0.965 moles. Putting this value in the ratio, we have 0.965 for strontium oxide and X for strontium. By cross multiplying, we can find the value of X. So X will be equal to 0.965 into 3 divided by 6. X is equal to 0.4825 moles. This is the number of moles of strontium metal. Now let's convert this moles into mass. We have mass is equal to moles into mR, or atomic mass in this case. Putting values, we have 0.4825 moles of strontium into atomic mass of strontium, which is 87.6. It comes equal to 42.26 grams. The answer is therefore 42.3 grams. Question 3. A single p32 nucleus can be produced when a single s32 nucleus joins with particle X. In the process, a proton is emitted. What is particle X? Let's write the equation for this reaction. We have sulfur 32 along with X, and it forms phosphorus 32 along with the proton. The atomic number of sulfur is 16, for phosphorus it is 15, for a proton it is 1. So we can see that the number of protons are balanced on both sides of the equation. We have 16 protons on the reactant side and 16 protons on the product side. Let's find the number of neutrons. For sulfur, it will be 32 minus 16 equals 16 neutrons. On product side, we have phosphorus 32, so 32 minus 15 is equals to 17 neutrons. So we can see that one neutron is being added in sulfur in order to produce phosphorus. So particle X must be a neutron. The answer is therefore C. Question number 4. In which of the following, when in liquid form, are there only intermolecular forces based on temporary dipoles between the particles? We know that temporary dipoles is between non-polar molecules, so let's find the polarity. We have bromine. Bromine is non-polar as in Br2. Both atoms have the same electronegativity. In ethanol we have oxygen and hydrogen, and therefore hydrogen bonding takes place, and it is a polar compound. The oxygen has partial negative charge and hydrogen has partial positive charge. In HCl, again the compound is polar in nature because chlorine is more electronegative as compared to hydrogen. In D we have water. Water is also a polar compound because oxygen is electronegative and hydrogen is electropositive. So in water, hydrogen bonding takes place. In ethanol we have hydrogen bonding. In water we have hydrogen bonding. In hydrogen chloride the compound is polar, so therefore the forces are permanent dipole-dipole forces. So in bromine molecular, when the molecules are close together, only temporary dipoles are present. Therefore, answer is A. Question number 5. Copper has a high melting point. What is the reason for a high melting point of copper? Now we know that copper is a metal, and what happens in metal that the positive ions are surrounded by negative electrons on all sides, and again negative electrons are surrounded by positive ions. So because of the presence of positive ions and a sea of electrons, the force of attraction are very strong. Let's move towards the options. In A we have strong attractive forces between copper atoms only. Now we can see that these are copper positive ions and negative electrons which are strongly attracted to each other, so therefore A is incorrect. B. Strong attractive forces between copper ions and delocalized electrons are present. Now it is obvious from the diagram, so therefore this is correct. C. Strong attractive forces between copper ions only. Now we can see that the copper ions are positively charged, so therefore there are no attractive forces among positive ions, as similar charges repel each other. So this is incorrect. D. Strong attractive forces between copper atoms and delocalized electrons. Now this is incorrect because copper positive ions are attracting negative electrons. The only correct option is therefore B. Question number 6. Which pair of standard enthalpy changes are numerically equal? A. Atomization of CH4 gas and formation of CH4 gas. Atomization means that the compound is changed back into respective atoms. We have 1 atom of carbon and 4 atoms of hydrogen, and both are in gaseous state. While formation of CH4 means that the CH4 gas is being formed from its elements in their standard states. Now element is carbon and hydrogen exists as H2. So carbon will be solid and hydrogen will be gas. Now we can see that in atomization hydrogen is in atomic form, while in formation hydrogen is in molecular form. Again, carbon is in gaseous atomic form in atomization, while it is in solid form in formation. So therefore both are not equal. This is incorrect. B. Combustion of methanol liquid and combustion of graphite plus 2 into combustion of hydrogen gas. Let's first write the equation for combustion of methanol. We have CH3OH in liquid form. It combusts in the presence of oxygen to form carbon dioxide and water. We can balance this equation by writing 2 with water and 3 by 2 with oxygen. Combustion of graphite will be carbon in the form of graphite plus oxygen. It will form CO2. And combustion of hydrogen will be H2 gas plus oxygen. It forms H2O multiplied by 2. Now we can see that we have same products in both reactions. We have 1 mole of carbon dioxide and 2 mole of water. Again we have 1 mole of carbon dioxide and 2 moles of water. But we can see that the reactants are different. One is methanol, second is carbon and hydrogen. So therefore as the reactants are different, so the enthalpy change will also be different. So B is incorrect. C. Combustion of graphite and formation of carbon dioxide. Now we can write the equation for combustion of graphite. Carbon solid combusts in the presence of oxygen to form CO2 gas. Now we can also write the equation for formation of carbon dioxide. So carbon dioxide is formed from its element. One of the element is carbon and the other element is oxygen. And the standard state is that carbon is in solid form and oxygen is in gaseous form. Now we can see that the reactants and products are same and the number of moles are also same. So therefore they are numerically equal values. So C could be correct option. D. Neutralization of HCl with NaOH aqueous and formation of H2O. Neutralization of HCl and NaOH can be shown by this equation. We have HCl aqueous, sodium hydroxide aqueous. It forms sodium chloride along with water. Secondly, we can write the equation for formation of H2O liquid. So H2O liquid will require elements hydrogen and oxygen in their standard states. Now we can see that in both reactions same number of moles of water are being formed, but we have different reactants. For neutralization we have HCl, NaOH and sodium chloride is also formed, so therefore the values will be numerically different. So it is incorrect. The answer is therefore C. Question 7. An energy cycle is drawn for the following reaction. We have bromine liquid which reacts with fluorine gas to form bromine trifluoride. The standard enthalpy of formation of BrF3 liquid is minus 301 kilojoules per mole. The enthalpy change of BrF3 liquid to BrF3 gas is plus 44 kilojoules per mole. What is the average bond energy of the BrF bond in BrF3? Br2 liquid and 3 fluorine molecules are the reactants, and we can see that they convert into this product. Now this reaction can also go in this direction. First BrF3 is formed in liquid form, then BrF3 is formed in gaseous form, then we have the product. So the product is common from both sides, so we can apply Hess's law. According to Hess's law, the product formed in one step, this is the one step or single step, will be equal to the product formed in several steps. Let's find the energy of each step. We have standard enthalpy of formation of BrF3 liquid equals minus 301 kilojoules per mole. Now this is for 1 mole, and we can see that 2 moles of BrF3 are being formed. So the energy will be equal to minus 301 into 2, which is equal to minus 602 kilojoules per mole. Enthalpy change of BrF3 liquid to BrF3 gas is 44 kilojoules per mole. Now we can see that 2 moles of BrF3 liquid are converted into 2 moles of BrF3 gas. So therefore plus 44 will be multiplied by 2. So it comes equal to plus 88 kilojoules per mole. In this step we can see that BrF3 gas is being converted into its respective atoms. So we can find this as X. So X will be the atomization energy. Now applying Hess's law, we can say that the energy in one step, which is 698 kilojoules, is equal to the energy involved in several steps. So we have minus 602 plus 88 and X. So X will be equal to 698 plus 602 minus 88. As we have 2 moles of BrF3 converted into its respective atoms, so X is the energy for 2 moles of BrF3. So for 1 mole the energy will be equal to 606 kilojoules per mole. Now we can see that in 1 mole of BrF3 we have 3 BrF bonds. So 3 BrF bonds will be equal to 606. So in order to find the energy for 1 BrF bond, we will have to divide this by 3. So it will be equal to 202 kilojoules per mole. And this is for 1 BrF bond. The answer is therefore B. Question number 8. In which reaction does the greatest change in oxidation number of sulfur occur? Let's find the oxidation states. Sulfur is in solid form, so oxidation state is 0. Let's find oxidation state of sulfur in SO2, SO3, H2SO4, H2S2O7. In SO2 we have 1 sulfur, 2 oxygen atoms and overall charge is 0. In SO3 we have 1 sulfur, 3 oxygen atoms and overall charge is 0. In H2SO4 we have 2 hydrogens, 1 sulfur, 4 oxygens and charge is 0. In H2S2O7 we have 2 hydrogen atoms, 2 sulfur, 7 oxygens and overall charge is 0. As the oxidation state on oxygen is -2, so for 2 oxygen the charge will be -4 or sulfur is equal to +4. For SO3 we have 3 oxygen atoms, so it will be -6 or sulfur is equal to plus 6. For H2SO4 the charge on hydrogen is plus 1, so we have plus 2 for 2 hydrogen, sulfur, and for 4 oxygen it will be negative 8. So we can write S minus 6 or S will be equal to plus 6. For H2S2O7 we have 2 hydrogen atoms with plus 2 oxidation state, 2 sulfur, 7 oxygen will be equal to negative 14. So 2 sulfur minus 12 equals 0. So 2 sulfur is equal to plus 12, and for single sulfur the oxidation state will be plus 6. Let's write these oxidation state. For sulfur dioxide we have plus 4, so the change is from 0 to plus 4, which equals plus 4 change in oxidation state. For sulfur dioxide again we have plus 4, in sulfur trioxide we have plus 6, so moving from plus 4 to plus 6 the change in oxidation state is plus 2. Again in sulfur trioxide we have plus 6, in sulfuric acid we have plus 6, in H2S2O7 we have plus 6, so from plus 6 to plus 6 there is 0 change in oxidation state. In H2S2O7 we have plus 6, again plus 6 in H2SO4, so the change in oxidation state is 0. The greatest change is observed in part A, which is plus 4, so therefore answer is A. Question number 9. The first stage in the chloride process for the manufacture of titanium consists of the following reaction. What is reduced in this reaction? Let's find the oxidation states. The chlorine is in molecular form, so the oxidation state is 0. Similarly, carbon is in element form, so the oxidation state is also 0. For others we can find, for TiO2 the overall charge is 0. For TiCl4 charge is 0. For CO the charge is 0. For CO2 the charge is also 0. So we have 1 titanium, 2 oxygens, 1 titanium, 4 chlorine atoms, 1 carbon, 1 oxygen, 1 carbon and 2 oxygen in CO2. The charge on 1 oxygen is negative 2, so it will be minus 4. Titanium is equal to plus 4. For 1 chlorine, charge is negative 1, so titanium will be equal to plus 4. For oxygen the charge is negative 2, overall 0, so carbon will be equal to plus 2. We have 2 oxygen atoms, so negative 4, and carbon is equal to plus 4. Now we can write the oxidation states: plus 4, plus 4, plus 2, plus 4. The charge on 1 chlorine atom is negative 1. A is carbon. We can see that it has changed from 0 to plus 2 and 0 to plus 4, so it has oxidized. So this is incorrect. B is chlorine. So for chlorine we can see that it has gone from 0 to negative 1, so it has reduced. This could be correct. C is oxygen. Oxygen is negative 2 on the reactant side and negative 2 on the product side, so no change has taken place. For titanium, the oxidation state is plus 4 on both sides, so there is no change. Correct option is therefore B. Question 10. In aqueous solution, sulfuric acid dissociates as shown. This reaction goes to completion, and this is the second reaction in the dissociation, which reaches equilibrium with constant Kc. Analysis of 2 mole per decimeter cube solution of H2SO4 found the hydrogen sulfate concentration to be 1.988 mole per decimeter cube. What is Kc? Stop. We can write the equation again. We have H2SO4 and it dissociates completely, 100% dissociation into these ions. Initially we have 2 mole per decimeter cube of sulfuric acid, so it will form 2 mole per decimeter cube of hydrogen sulfate and 2 mole per decimeter cube of H plus ions. This is because the reaction goes to completion. After completion of reaction, only products are present and there is no reactant present. The second reaction is HSO4 negative, which converts into sulfate ions and H positive ions. So initially we have 2 moles of HSO4 negative, so we can write 2 moles. Now as HSO4 negative has not dissociated yet, so therefore the concentration is 0 for sulfate ions. Second ion is H positive ions. As we know that H positive ions were already present in the solution, so we have 2 moles of H positive ions initially. As the concentration of product is 0, so this reaction will move in the forward direction in order to attain equilibrium. So some amount will be removed from hydrogen sulfate and the same amount will be produced for sulfate and same amount will be produced for H positive. So we can write that amount by X. This step is the change in concentration. Now third step is the equilibrium concentration. In the question we can see that HSO4 concentration is equal to 1.988 mole per decimeter cube. So this is the equilibrium concentration of HSO4 negative. As the change was 2 minus X, so we can find the value of X as 2 minus X is equal to 1.988. So X equals to 2 minus 1.988, which is equal to 0.012. Initially sulfate was 0 and the change has occurred to be X, so the total change is 0 plus X, which will be equal to 0.012. For H plus initially it was 2 and the change is 2 plus X, so it will be 2 plus 0.012 at equilibrium, which equals to 2.012 mole per decimeter cube. Let's find Kc. For equilibrium reaction, the Kc is equal to the concentration of product, which is sulfate and H positive divided by concentration of reactants, which is HSO4 negative. Now putting the values of equilibrium, we have 0.012 for sulfate, 2.012 for H plus and 1.988 for HSO4. So the value of Kc comes equal to 1.214 exponential minus 2 mole per decimeter cube. The answer is therefore C, 1.214 exponential minus 2 mole per decimeter cube. Question 11. An autocatalytic reaction is a reaction in which one of the products catalyzes the reaction. This is the definition of autocatalytic reaction. Which curve would be obtained if the rate of an autocatalytic reaction is plotted against time? This question can be explained by the help of an example. We have oxidation of ethane dioic acid by acidified KMnO4. So the equation will be MnO4 negative plus H positive plus we have ethane dioic acid, which is COOH, and the oxidation takes place. Mn plus 2 is formed along with CO2 and H2O. The number of moles in balanced equations are 2, 6, 5, 2, 10 and 8. Now this reaction is autocatalytic reaction because the product Mn plus 2 is also acting as a catalyst. When the reaction starts, we have maximum amount of reactants and zero amount of products present. So as there is no catalyst when the reaction starts, so therefore the reaction rate will be slow. Now what happens that when some amount of Mn plus 2 is formed, the reaction rate gradually increases. As more amount of Mn plus 2 is formed, the reaction rate also increases. Now as the amount of reactant is limited, so therefore the concentration of reactant will start to decrease after a certain time. So when the concentration of reactants decrease, then the rate of reaction also decreases. So initially the rate of reaction will be slow as no catalyst is present. Then gradually the reaction rate will be increasing as more catalyst is being formed, and at last the reaction rate will decrease because the concentration of reactant decreases. So the only graph that can show this relation is C. The reaction rate is increasing, then it goes to maximum and then starts to decrease with time. Question 12. X and Y are two elements in the period 3 of periodic table. They combine to form compound Z. X forms a soluble acidic oxide. The oxidation number of X in this oxide is +4. Y forms an amphoteric oxide. What is the formula of compound Z? The elements in period 3 are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and so on. Now the oxides will be sodium oxide, magnesium oxide, aluminum oxide, silicon oxide, phosphorus oxide, sulfur oxides. In the question they have stated that X forms a soluble acidic oxide. Now we know that non-metal oxides are acidic in nature, so therefore it could be silicon dioxide, phosphorus oxide, or the oxides of sulfur, as these are acidic in nature. And it says Y forms an amphoteric oxide. The only oxide in group 3 which is amphoteric in nature is aluminum oxide. The oxidation number of X is given as +4. Let's find the oxidation states. In silicon we have +4. In phosphorus oxide we have +5. In sulfur dioxide again we have +4, and in sulfur trioxide we have +6. So from these observations we can say that element X could be silicon or sulfur. Element Y would be aluminum. As no silicon aluminum compound is given in the options, so therefore X is not silicon, it would be sulfur. Now aluminum is metal and the oxidation state is +3, while sulfur is non-metal and the oxidation state is -2. So the formula will be Al2S3. The correct option is therefore B. Question 13. This question is about two elements in group 2, Q and R. 3 of the statements shown are correct for metal Q. The one remaining statement is correct for metal R. Which statement applies to R? Let's first write the elements of group 2. We have beryllium, magnesium, calcium, strontium, and barium. Let's move towards the statement A. A saturated solution of the hydroxide of this metal has a higher pH value. Now we can say that the hydroxides of group 2 become more soluble moving down in group. So more soluble hydroxide means more higher pH, so it could be barium. B. This metal has a carbonate that is used in agriculture to reduce the acidity of soil. Now we can see that the carbonates of group 2 become more stable as we move down in the group. So it means barium carbonate is difficult to decompose, so it won't be barium carbonate. It could be calcium carbonate because we know that calcium carbonate forms calcium hydroxide, which reduces the acidity of the soil. C. This metal has greater atomic radius. As we know that the number of shells increase down in the group, so therefore barium would have the greatest atomic radius. So it could be barium. D. This metal reacts more quickly with cold water. The reactivity of group 2 metals also increase down the group with water, so therefore it should be barium. So A, C and D, these three properties are for barium, while B is for calcium carbonate, while B is for calcium. So metal Q is barium and R will be calcium. The correct option for calcium is B. Question 14. The electronic arrangement for atoms of 4 elements is given. Which element is the strongest oxidizing agent? We know that oxidizing agent oxidizes others while itself reduces. Now reduction means gain of electrons, so therefore it means that it gains electrons from other elements. Let's find the element based on the electronic configuration given. As there are 9 electrons in A, so there will be 9 protons and the element is fluorine. For B we have 12 electrons, so there will be 12 protons and it is magnesium. For C we have 17 electrons, so 17 protons for chlorine. For D we have 20 electrons, so 20 protons are for calcium. Now we know that non-metals gain electrons while metals lose electrons. So the answer must be a non-metal, so it could be A or C. Now among A and C we have fluorine and chlorine. Now fluorine is more electronegative than chlorine. It means that it is a stronger oxidizing agent as compared to chlorine. The answer is therefore A. Question 15. A student mixes pairs of chemicals together in separate test tubes. We have excess calcium plus water, barium chloride plus strontium hydroxide. Different reactions are given. How many of the mixtures produce a white solid product? Now let's find the products. First one is excess calcium solid plus water liquid. So it forms calcium hydroxide precipitate, which is very slightly soluble along with hydrogen gas. The color of calcium hydroxide is white. So this option is correct. Second one is barium chloride aqueous plus strontium hydroxide. Now the product formed will be barium hydroxide and strontium chloride. As both are soluble, so therefore no precipitate is formed or no solid is produced. So this is incorrect. Third one is calcium carbonate solid along with excess hydrochloric acid. So the product formed will be calcium chloride aqueous plus carbon dioxide gas plus water. As calcium chloride is also soluble in water and therefore no precipitate is formed. So this is also incorrect. In the last one we have magnesium sulfate along with barium nitrate. So the product formed will be magnesium nitrate aqueous along with barium sulfate. Now barium sulfate is insoluble and it is white solid. So therefore this reaction is correct, as two reactions form solid white product, so therefore answer is C. Question 16. With which compound does concentrated sulfuric acid reacts both as a strong acid and as an oxidizing agent? Oxidizing agent is the one that oxidizes others while reduces itself. First one is magnesium carbonate. Let's write the equation with sulfuric acid. We have concentrated sulfuric acid, H2SO4. It will form magnesium sulfate along with water and carbon dioxide. This is the acid carbonate reaction, and we can see that the oxidation state of magnesium is still the same. So magnesium is not oxidized, so therefore A is incorrect. B is potassium chloride. It is KCl with sulfuric acid. Now it is converted into potassium hydrogen sulfate along with HCl. The oxidation state of chlorine has not changed, so therefore H2SO4 does not behave as an oxidizing agent. Also, we know that concentrated sulfuric acid can oxidize bromide or iodide ions, but it cannot oxidize fluoride or chloride ions. As we have chloride in potassium chloride, so therefore it is not oxidized by sulfuric acid. Third reaction is with sodium bromide. Now as bromide is present, so therefore it will be oxidized by concentrated sulfuric acid. The first product formed is sodium hydrogen sulfate plus HBr. In second step, what happens that HBr again reacts with sulfuric acid and it forms bromine along with sulfur dioxide and water. The oxidation state of Br was -1 in NaBr, -1 in HBr and 0 in Br2. So from -1 it has moved to 0, so therefore this is oxidation. So sulfuric acid is behaving as an acid and also it is behaving as an oxidizing agent. So C could be correct. D is sulfur trioxide. Now sulfur trioxide is gas and it can dissolve in concentrated sulfuric acid to form H2S2O7, which is called oleum or fuming sulfuric acid. So H2SO4 only behaves as a solvent in this case, so D is also incorrect. The correct option is therefore C. Question 17. Ammonia can undergo an acid-base reaction with hydrogen chloride to form ammonium chloride. Which statement is correct? A. The ammonium ion is basic. As in ammonium ion we have 4 hydrogen atoms and the charge is +1. Now this ammonium ion can donate H positive. So whenever something can donate H positive ion, then it is acidic in nature, not basic. So A is incorrect. B. The hydrogen atom from HCl donates a lone pair of electrons to the nitrogen atom. As the reaction is NH3 plus HCl to form NH4Cl. We have lone pair on nitrogen atom and positive charge on hydrogen. So this lone pair is donated to this hydrogen atom to form a coordinate covalent bond, and ammonium ion is produced. So therefore the hydrogen atom accepts a lone pair of electron. It does not donate. This is also incorrect. C. The HNH bond angle in ammonia is the same as HNH bond angle in ammonium ion. In ammonia we can see that we have 3 single covalent bonds and 1 lone pair is present. So the bond angle is 107. While in ammonium ion 4 bonds are present and no lone pair is present. So as there are 4 bonds, so the bond angle is 109.5. So both bond angles are different. C is also incorrect. D. The HNH bond angle in ammonium ion, which is 109.5, is the same as HCH bond angle in methane. Now the structure of methane is like this. We have 1 carbon making 4 single covalent bonds, and the bond angle is 109.5. So D seems to be correct. Therefore D is the answer. Question number 18. What are the trends in the stated properties as group 2 is descended from magnesium to barium? First is the decomposition temperature of the carbonate. As we know that in group 2, the carbonates become more stable down the group. This is because size of cation increases, and as the size of anion is already greater, which is carbonate anion, so therefore the bond formed becomes stronger as the size of both cation and anion become equal. So it should be increases. Second is the first ionization energy. As we know that in group 2 the size of element increases down the group. This is because in each period 1 shell is added. So the first ionization energy is the removal of electron from the outermost shell. So when the outermost shell is away from the nucleus, then the ionization energy will decrease. So the first ionization energy decreases down the group. The answer is therefore D. Question number 19. Sulfur dioxide reacts with calcium hydroxide in the aqueous solution. What is the main product that is first formed? We can write the equation: sulfur dioxide plus calcium hydroxide. It forms calcium sulfite along with water. So therefore calcium sulfite is formed. So the answer is C. Question number 20. Structural and stereoisomerism should be considered when answering this question. Compounds X, Y and Z are shown. This is X, Y and Z. How many other isomers of C3H7ClO are there that are alcohols? Let's first draw the structures of X, Y and Z. In X we have 3 carbon atoms, 1 OH, 1 Cl and 1 hydrogen atom attached with the last carbon. Also with the Y we have 3 carbon atoms, and again in Z we have 3 carbon atoms. So X will be like this: 1, 2, 3 carbons, and with last carbon we have OH and Cl. For Y we have 3 carbons, and with the last we have OH and Cl. As for Z, we have 3 carbon atoms, and with the central carbon we have Cl and OH. In stereoisomerism, we have two types. Either there should be cis-trans isomerism, which needs a double bond between carbon atoms, or the second one must be optical isomerism, which needs a chiral center. Let's draw the structures that are different than X, Y, and Z. We have 3 carbon atoms, where OH is attached with the second carbon and Cl is attached with the third carbon. 3 hydrogen atoms are with this carbon, 1 with this, and 2 with this one. As we can see that the central carbon is attached to 4 different groups. One is OH, one is hydrogen, one is CH3, and one is CH2Cl. So therefore this is chiral carbon. So there must be an optical isomer of this compound. The numbering starts from this carbon atoms. As the substituent gets the least number, we have 1, 2, 3. So the name is 1-chloro-propane 2-ol. Another possibility is that we have 3 carbons and OH is attached with the first carbon atom and Cl is attached with the third carbon atom. Rest are the number of hydrogens. We have 2, 2 and 2 hydrogen atoms. As we can see that none of the carbon is chiral, so therefore there is no optical isomer for this compound. The name of this compound is 3-chloro-propane 1-ol. Another possibility is that we have 3 carbons, OH is attached with the first carbon atom and Cl with the second carbons. Filling hydrogen, we have 2 hydrogens, 1 and 3. The numbering starts from this carbon atom, so we have 2-chloro-propane 1-ol. The central carbon is attached with 1 hydrogen atom, 1 chlorine atom, 1 CH3 and 1 CH2OH. So all 4 groups are different, so therefore this is chiral carbon. And this must have an optical isomer. So we have 1-chloropropane 2-ol along with its optical isomer. We have 3-chloropropane 1-ol. Then we have 2-chloropropane 1-ol along with its optical isomer. So in total we have 5 new isomers that are being formed. So therefore answer is D. Question 21. 2 students each make a statement about 2-methyl-but-1-ene. Student 1 states that 2-methyl-but-1-ene has geometrical isomers. Student 2 states that 2-methyl-but-1-ene reacts with HBr in an addition reaction to give 1-bromo-2-methylbutane as the main product. Which students are correct? Let's draw the structure of 2-methyl-but-1-ene. So we have 4 carbon atoms in the long chain. As it is 1-ene, so the double bond is between first and second carbon. On second carbon we have methyl group, so it is CH3. Adjusting the number of hydrogens, we have H, H, H2, H3. Now let's find the geometrical isomer. For geometrical isomer there must be a double bond, and the carbons making double bond must have 2 different groups attached with it. So we can see that there is double bond present, but with the double bonded carbon atoms both atoms are same, so therefore this won't show geometrical isomer. So student 1 is wrong. Student 2 states the addition of HBr in addition reaction, so we can add HBr in this compound. In addition reaction, major product follows Markovnikov rule. According to this rule, the hydrogen atom attaches itself with the carbon atom that already has more hydrogens present in it. So hydrogen will move to this steric carbon and Pr will move to the other carbon. So let's draw the product. We have carbon, carbon CH3, CH2, CH3. Now there are 3 hydrogen atoms with this carbon and 1 bromine with this one. This is the major product. The other product is also formed, in which hydrogen is attached with this carbon and bromine is attached to the steric carbon, but that will be minor one. So the major product is this one. Let's find the name. In the long chain we have 4 carbons, 1, 2, 3, 4. With the second carbon we have methyl group and bromine. So the name is 2-bromo 2-methyl butane. So student 2 is also wrong. The answer is therefore D. Question 22. Which statement is correct when referring to the complete combustion of PVC? PVC is polyvinylchloride. The general formula of PVC is C2H3Cl with n number of repetitions. Let's move towards the option A. A gas is made which contributes to global warming. Let's find the combustion products of PVC. In the presence of oxygen, it forms carbon dioxide, water and HCl. Now we can see that among the products, carbon dioxide is present, which contributes to the global warming. So A could be correct. In B we have carbon dioxide and water are the only products. We also have HCl, so therefore B is incorrect. In C, it says if water is used to clean the exhaust gases, the water becomes alkaline. Now exhaust gases consist of HCl and CO2. Both are acidic in nature, so therefore the water will become acidic, not alkaline. So C is incorrect. In D, there is no need to treat the exhaust gases as the products are non-hazardous. As HCl is acidic gas and it is hazardous, so therefore D is also wrong. The correct option is A. Question 23. Iodoethane CH3CH2I reacts with aqueous silver nitrate at 50 degrees centigrade. A precipitate forms during this reaction. Which row of the table is correct about this reaction? We have iodoethane CH3CH2 and I. Iodine is more electronegative, so the charge is partial negative, while carbon will become partial positive. Now this is going to react with silver nitrate, aqueous. It means we have silver nitrate present in the form of ions and we also have water present. As the temperature is 50 degrees centigrade, so water will act as a nucleophile and OH will attach itself with the partial positive carbon atom. So by nucleophilic substitution, we would have the product CH3, CH2, OH and I negative is removed. We also have silver nitrate present. So silver ion will react with iodide to form AgI. Let's move towards the option. The type of organic reaction was substitution and OH was acting as a nucleophile, so this is nucleophilic substitution reaction. So it could be C or D. Second is the color of precipitate. As silver iodide is formed, which is yellow in color, so therefore the color of precipitate will be yellow. Correct option is therefore D. Question 24. A student converts 1-iodopropane C3H7I into butanoic acid, which is C3H7CO2H, by a two-stage chemical synthesis. In the first of the two stages, which reagent is reacted with 1-iodopropane? As we can see that in the reactant we have 3 carbon atoms, while in butanoic acid we have 3 plus 1, 4 carbons present. So the first step would be to increase the number of carbon atoms, which can be done by the presence of cyanide ion, and 3 carbons will be converted into 4 carbon nitrile compound. In second step, the nitrile is then converted into carboxylic acid upon acid hydrolysis. We can write the chemical reaction like this. We have C3H7I. It reacts with cyanide and forms C3H7CN. Now this has become a nitrile. Cyanide has replaced iodine, so I negative will also be formed. In the second step, acid hydrolysis takes place in the presence of HCl and H2O, and nitrile will convert into carboxylic acid along with ammonium chloride. Let's move towards the options. We have aqueous sodium hydroxide. This is incorrect. Ethanolic ammonia. Ethanolic potassium cyanide, as Cn negative is present, so this is the correct option. D. Ethanolic sodium hydroxide. This is also incorrect. The answer is therefore C. Question 25. 1-chloro-1-methyl-cyclohexane is hydrolyzed by heating with sodium hydroxide. We have the product. The reaction pathway is shown. One carbon atom in 1-chloro-1-methyl-cyclohexane is bonded to 3 other carbon atoms. What is the charge on this carbon atom at point Z? Let's find the carbon atom that is bonded to 3 other carbon atoms. We have this carbon, and it is bonded with this carbon, and this carbon, so this is tertiary halogenoalkane. Now we can see that in this reaction OH is replacing Cl, so therefore this is nucleophilic substitution reaction. The nucleophilic substitution of tertiary halogenoalkane takes place in 2 steps. In the first step, what happens that carbocation is formed. In the second step, the carbocation will react with Cl negative to form substituted product. Now the first step is slow step, so it will need high activation energy, so this hump is for first step. In second step, carbocation has been formed, which reacts with chlorine to form the product. So the energy for second step is low, so the hump is smaller. As the charge on carbocation is +1, so therefore answer is D. Question 26. An alcohol with the molecular formula C5H12O decolorizes warm acidified potassium manganate 7. The alcohol also gives a yellow precipitate with alkaline aqueous iodine. What could be the identity of the alcohol? In the reaction they have given acidified potassium manganate, which is oxidizing agent. The second reaction is given with alkaline aqueous iodine and yellow precipitate is formed. Now we must know that for alcohol, in order to give positive result for this reaction, there must be a methyl group attached with the carbon having alcohol functional group. If no CH3 is attached with the carbon atom having OH group, then yellow precipitate is not formed. Let's move towards the option. We have 2-methylbutane 2-ol. Let's draw the structure. A. We have 4 carbon atoms. On second carbon we have methyl functional group and also alcohol functional group. B is 3-methylbutane 2-ol. So again we have 4 carbon atoms. On second carbon we have alcohol functional group, and on third carbon we have methyl functional group attached. C is pentane 1-ol, so we have 5 carbon atoms, and the alcohol group is attached with the first carbon atom. In D we have pentane 3-ol, so we have 5 carbon atoms, and alcohol is attached with the third carbon. In A we have this carbon that is attached with OH functional group, and we can see that this carbon is attached directly with 3 other carbon atoms, so this is tertiary alcohol. And tertiary alcohol does not oxidize in the presence of acidified KMnO4. Let's move towards B. We have this carbon that is attached with OH functional group, and we also have a CH3 directly attached with this carbon. As the steric carbon is secondary alcohol, so it will oxidize to ketone functional group. We also have a CH3 directly attached, so therefore alkaline aqueous iodine will also give positive yellow precipitate of CHI3. So B could be the correct option. In C we have carbon atom attached with OH group, and this is primary alcohol, so the primary alcohol will oxidize itself to aldehyde. The second reaction is with alkaline aqueous iodine, as there is no CH3 directly attached with this carbon, therefore this won't give yellow precipitate. Similarly, in D we can see that carbon atom attached with OH is secondary alcohol, so this will oxidize into ketone. But we can see that no CH3 group is directly attached with this carbon atom, so therefore it won't give yellow precipitate. The only alcohol giving both positive results is B. Question 27. Which pair of test results would prove that a substance X is a ketone? A. X has no reaction with Tollens reagent. As we know that Tollens reagent gives positive result only with aldehyde, so therefore X is not aldehyde. It can be anything other than aldehyde. Second reaction is X reacts with alkaline aqueous iodine. Now alkaline aqueous iodine can give positive result with secondary alcohol having methyl functional group. It can also give positive result with aldehyde having CH3 directly attached with carbonyl carbon. It can also give positive result with ketone having CH3 group attached with carbonyl carbon. So A cannot prove that X is a ketone. B. X is reduced by lithium aluminum hydride, and X is oxidized by acidified dichromate 6. Now lithium aluminum hydride can reduce ketone back to secondary alcohol. It also says X is oxidized by acidified dichromate 6. Now we know that ketone is not further oxidized. So B is also incorrect. Let's move towards C. X reacts with 2,4-dinitrophenylhydrazine reagent. Now 2,4-DNPH can give positive result with carbonyl carbon, so therefore it can prove that the substance is either an aldehyde or a ketone. X has no reaction with valence reagent. So as aldehyde does react with valence reagent while ketone does not, so therefore ketone is confirmed. So C could be correct option. In D, it says X reacts with hydrogen cyanide. X is reduced by lithium aluminum hydride. Now hydrogen cyanide can react with both aldehydes and ketone to form nitriles. In second reaction, it is reduction by lithium aluminum hydride. So both aldehydes and ketones can be reduced by LiAlH4. So we cannot differentiate between aldehyde and ketone based on these reactions. So D is incorrect. The correct option is therefore C. Question 28. Carbon is found in spearmint oil. This is the structure. We can see that we have ketone functional group and also alkene is present. Which product is formed when carbon is reacted with NaBH4? Now NaBH4 is a reducing agent and it can reduce ketone functional group to secondary alcohol group, while alkene is not reduced. Let's move towards the option. In A, we can see that carbonyl carbon has converted into secondary alcohol and alkene has not changed, so A could be correct. In B, we can see that carbonyl carbon has not changed, so B is incorrect. In C, again carbonyl carbon is not changed. In D, we have secondary alcohol, which is correct, but alkene has also converted into alkane, which is incorrect. So the correct option is A. Question 29. Which compound is chiral and reacts with sodium carbonate to give carbon dioxide? Now chiral carbon is the one that is attached with 4 different groups or elements. Let's find out the chiral carbon. Now we can see that the carbon atoms in A are making double bonds. This is making double bond with oxygen, so it is not chiral. This is making double bond with the other carbon, so these are not chiral. Again, this is making double bond with oxygen, so this is not chiral. So none of the carbon atoms in A is chiral, so therefore A is incorrect. In B, we can see that this carbon is making bond with 3 similar atoms, so this is not chiral. The carbon atom present here is making 4 bonds, one with CH3, one with OH, one with this double bonded and one with this single bonded chain. So this is chiral carbon. This carbon is making 2 bonds with hydrogen, so it is not chiral. Again, 2 hydrogen atoms are attached, 2 with this one. This is making a double bond. So only one carbon is chiral, which is shown by the red dot. Now in B, we can see that the functional group attached is alcohol and alkene. Both alcohol and alkene does not give carbon dioxide with sodium carbonate, so therefore B is incorrect. Let's move towards C. We can draw the structure by showing all the bonds. We have HC, double bond O, O, carbon, hydrogen, CH2, Br, and CH3. Now we can see that only this carbon is attached to 4 different groups. One is CH3Br, one is hydrogen, one is CH3 and one is OCOH. So this is chiral carbon. The functional group present is ester. So ester does not give carbon dioxide with sodium carbonate. So C is incorrect. Let's move towards D. We can draw the structure CH Br CO2 H CH2 and CH3. Now we can see that this carbon is attached to 4 different groups. One is H, one is Br, one is CO2H, and one is ethyl functional group. So this carbon is chiral. And we also have carboxylic acid functional group attached, and carboxylic acid does react with sodium carbonate to give carbon dioxide along with the sodium salt. So therefore correct option is D. Question 30. The skeletal formula of compound X is shown. What is the molecular formula of compound X? Let's find the number of carbons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. Now let's draw the number of hydrogens. We have 2 hydrogen with this carbon, 1 with this, 3 with this, 1 hydrogen is this one, 2 with this, 2, 1, 3, 3. So there are 18 hydrogen atoms and 1 oxygen atom is present. The correct answer is therefore A. Question 31. Nitrogen forms a number of oxides. Their enthalpies of formation are given. The enthalpy of formation of NO is plus 90. For N2O it is 82. For NO2 it is plus 33. Which statements are correct? 1. If N2O gas is oxidized by oxygen gas to NO2 gas, 16 kilojoules is released per mole of N2O. We can solve this by writing an equation. N2O reacts with oxygen and forms NO2. The elements present are nitrogen and oxygen. So the elements combine to form the reactants, or the elements can directly form the product, which is NO2. Let's balance. We have 2 nitrogen atoms on the reactant side, so we can write 2 with nitrogen. Oxygen can be balanced by writing 2 and 3 by 2 with this O2. This arrow shows the enthalpy change of formation of N2O, and it is given in the question as plus 82 kilojoules per mole. The other arrow shows the enthalpy of formation of NO2, and its value is given in the question as plus 33 kilojoules per mole. As we can see that 2 moles of NO2 are being formed, so it will be 33 into 2 equals 66 kilojoules per mole. Third arrow is about the oxidation of N2O, and we have to find the value of X. Applying Hess's law, we have these 2 steps that forms the product and this single step that forms the same product. So we can write enthalpy of formation of N2O plus X will be equal to 2 into enthalpy of formation of NO2. Now putting values, we have 82 plus X equals 66. So X will be equal to 66 minus 82, which is equal to negative 16 kilojoules per mole. As the enthalpy change is negative, so it means that this energy is released. And also 1 mole of N2O were present, so it is per mole of N2O. So option 1 is correct. Option 2, the decomposition of N2O gas to nitrogen gas and oxygen gas is exothermic. Among these values we have the enthalpy of formation of N2O, and enthalpy of formation is that when a compound is formed from its element in their standard states. So we can write this equation as the reaction is enthalpy of formation in the forward direction and its value is positive. So the decomposition will be the reverse of formation. So the decomposition must be negative. So therefore decomposition would be exothermic. So option 2 is also correct. Moving towards option 3, the reaction between NO and oxygen is exothermic. Let's write the equation. We have NO, oxygen, it reacts to form NO2. The elements are nitrogen, oxygen. The elements first combine to form the reactants and they can also form product. We can balance nitrogen, so we have 2 moles of NO and 2 moles of NO2. We can also balance oxygen by putting 2 moles. Now the first arrow is the formation of NO. So the energy is given, it is plus 90 kilojoules per mole. As we have 2 moles of NO, so 2 into 90, it will be equal to 180 kilojoules per mole. Second arrow shows the formation of NO2. So as energy for 1 mole of NO2 is plus 33, so for 2 moles it will be 33 into 2, 66 kilojoules per mole. Now according to Hess's law, this is a 2-step process and this is 1-step process. We can find whether X is negative or positive. So 180 plus X equals 66. So X is equal to 66 minus 180 and it is equal to minus 114 kilojoules per mole. As the energy is negative, so it means that the reaction is exothermic in nature. So 3 is also correct. So therefore answer is A. Question 32. Which statements are correct? 1. Enthalpy of combustion of hydrogen is equal to enthalpy of formation of H2O. Now we can write the combustion of hydrogen. Hydrogen plus oxygen, it combines to form water. We can balance number of oxygen atoms by writing 1 by 2. Second is the enthalpy of formation of water. Now we know that in enthalpy of formation of water, 1 mole of water is formed from the elements in their standard states. So therefore the equation is same for enthalpy of combustion and enthalpy of formation of water. So 1 is correct. 2. Enthalpy of formation of hydrogen is equal to enthalpy of atomization of hydrogen. Now as H2 is already in molecular form and therefore the enthalpy of formation of H2 will be equal to 0. While the enthalpy of atomization of hydrogen means that hydrogen molecule converts into hydrogen atoms. So this will be endothermic in nature. Multiplying with negative, the value will become negative. So therefore still this is unequal to 0. So the enthalpy of formation of hydrogen is not equal to the enthalpy of atomization of hydrogen. So 2 is incorrect. Third is the enthalpy of solution of HCl. Now enthalpy of solution is the enthalpy change when 1 mole of HCl is dissolved in water to form infinitely dilute aqueous solution. Second is the enthalpy of hydration of H plus ion. So we can write H plus plus water. It is hydrated to form H plus aqueous. Now it moves from gaseous state to aqueous state. Second is the enthalpy of hydration of Cl negative. Again it is in gaseous state and hydration makes it aqueous. Now as hydrogen gas and Cl negative gas is in atomic form, while HCl is in molecular form, so therefore enthalpy of solution of HCl is not equal to the enthalpy of hydration of H plus and enthalpy of hydration of Cl negative. 3 is therefore incorrect. The only correct option is 1, so therefore answer is D. Question 33. The units of Kc for an equilibrium reaction are per mole into decimeter cube. What could be the equation for the equilibrium? Mole per decimeter cube is used for solutions. So A is in aqueous form, B is in aqueous form, C is solid, so therefore there is no concentration of C, and D is also in aqueous form. Let's find the units for first equation. We have product concentration divided by reactant concentration raised to the power their number of moles, or we can write mole per decimeter cube divided by mole per decimeter cube for A into mole per decimeter cube of B. So both these cancel out and the answer is per mole decimeter plus 3. So option 1 is correct. Option 2, P is aqueous, Q is aqueous, R is aqueous. So we can write R concentration divided by concentration of P into concentration of Q. Again we can see that we have mole per decimeter cube for R as 1 mole is present, mole per decimeter cube for P into mole per decimeter cube of Q. So the answer is again per mole decimeter plus 3. So 2 is also correct. Option 3, W is aqueous, Q has 2 number of moles, it is also aqueous, Y is aqueous, C is aqueous. So we can write Y concentration into concentration of Z divided by concentration of W into concentration of X raised to the power its number of moles, which is 2. Now we can find the units: mole per decimeter cube for Y, mole per decimeter cube for Z, mole per decimeter cube for W, and mole square decimeter minus 6 for X square. Cancelling out the values, we have per mole decimeter plus 3 left. So 3 is also correct. Therefore answer is A. Question 34. Methanol can be produced industrially by reacting carbon monoxide with hydrogen. This is the equation. Enthalpy change is negative. The process can be carried out at 4 exponential 3 kilopascals and 1150 Kelvin temperature. Which statement about this reaction are correct? Number 1. Increasing the temperature will increase the rate of reaction because more effective collisions will occur. Now what happens when temperature is increased? The kinetic energy of molecule also increases. So number of collisions will increase, and it is possible that effective collisions are also increased. So it results in increasing the rate of chemical reaction. So therefore option 1 is correct. Option 2. Lowering the temperature will reduce the rate of reaction because the forward reaction is exothermic. Now lowering the temperature does reduce the rate of reaction, but this reason given is incorrect. If the forward reaction is exothermic, the lowering temperature will shift the equilibrium in the forward direction. It will also reduce the rate of chemical reaction. So 2 is incorrect. 3. Increasing the pressure will reduce the rate of reaction because there are a large number of moles on the left side of the equation. Now increasing the pressure makes the gas molecules come close together and the rate of reaction will also increase. So 3 is incorrect. As only option 1 is correct, so therefore answer is D. Question 35. Which rows correctly show the relative electrical conductivities of the sets of 3 period 3 elements. We know that in period 3 sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine are present. Among these metals, sodium, magnesium and aluminum, the electrical conductivity increases along the period. This is because sodium can lose just 1 electron, magnesium can lose 2 electrons and aluminum can lose 3 electrons. So increasing the number of electrons also increases the conductivity. Silicon is a semiconductor. So its conductivity is less than these metals, while phosphorus, sulfur and chlorine are insulators. Moving towards the option, in 1 sodium has the greatest conductivity. It is more than silicon and silicon is more than chlorine. So we can see that chlorine is insulator, silicon is semiconductor and sodium is a metal. So 1 is true. In second, we can see aluminum, then magnesium, then phosphorus, as aluminum is more conductive as compared to magnesium and phosphorus is insulator. So therefore this series is also correct. Option 3, sulfur is greater than silicon and silicon is greater than phosphorus, as sulfur is an insulator, so therefore 3 is incorrect. Both option 1 and 2 are correct, therefore answer is B. Question 36. 3 test tubes X, Y and Z each contain water. A small amount of sodium chloride is added to test tube X. Silicon chloride is added to Y. Aluminum chloride is added to Z. After a short time, 2 drops of universal indicator solution are added. Which statement can be correct? Now we can see that sodium chloride is a neutral salt and it forms sodium ions and chloride ions. Therefore pH must be equal to 7. For silicon chloride, we know that silicon chloride is acidic in nature, so therefore it will react with water and form silicon dioxide along with HCl. So the solution will be acidic. For aluminum chloride reacts with water to form aluminum hydroxide along with HCl. Again, the solution will be acidic in nature. Aluminum hydroxide formed is insoluble in water, so the only ions present will be of HCl, so therefore pH will be lower. Moving towards the option, in 1 the pH in test tube X is 7. This is correct because it is sodium chloride. The pH in test tube Y is 2, as the solution is acidic, so this could be true. In third, the solution is also acidic, so therefore option 3 is also true. As all 3 options are correct, therefore answer is A. Question 37. The structure of compound R is shown. We can see that the compound R comprises of a ketone and carboxylic acid functional group. Which statement about compound R are correct? Number 1, it has an MR of 116. Let's find the number of carbon atoms and hydrogen atoms. We have 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. And there are 3 oxygen atoms present, so we can write O3. So for carbon it will be 12 into 5 equals to 60. For hydrogen it will be 1 into 8 equals 8. For oxygen it will be 16 into 3 equals 48. Adding these 3 we can get 116. So option 1 is correct. Option 2, it contains 2 groups that show strong absorption between 1640 and 1740 per centimeter in its infrared spectrum. Now, between these values, carbonyl carbon shows the sharp peak. and this carbonyl could be from carboxylic acid or aldehyde or ketones. Option 2 is therefore correct. Option 3, its only infrared absorption between 2500 and 3000 per centimeter is sharp and strong. Now the peak between 2500 to 3000 is because of the OH bond present in carboxylic acid. But it is not the only sharp and strong peak. We also have carbonyl carbon peak that is sharp and strong. So option 3 is incorrect. Therefore answer is B. Question 38. During the bromination of methane, the free radical CH3 dot is generated. A possible termination step of this reaction is the formation of C2H6 by the combination of two free radicals. What could be produced in a termination step during the bromination of propane? Option 1, we can draw the structure. We have carbon, 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 then methyl group attached, then CH2 and CH3. Now the radicals would be same in both situations. So we have CH3, CH2 radical along with CH, CH3, CH2, CH3 radical. As both radicals are unequal, so therefore 1 is incorrect. Option 2, the structure would be CH3, CH, CH3, CH, CH3, CH3. So the radicals that would form this compound would be CH3, CH, this radical, and this one. Now as both radicals are of propane, so therefore option 2 seems to be correct. Moving toward third option, we have CH3, CH2, CH2, CH, CH3, and again CH3. Now the propane radicals could be these. The radicals responsible for this compound could be CH3, CH2, CH2, and CH. As both radicals are of 3 carbon atoms, so 3 is also correct. As option 2 and 3 are correct, therefore answer is C. Question 39. 3 reactions of primary alcohols are listed. Which reactions give water as one of the products? Number 1 is the reaction with ethanoic acid. Now we know that primary alcohol reacts with ethanoic acid to form ester along with the production of water molecule. So option 1 is correct. In option 2, the reaction is with concentrated HBr. We can write the reaction with primary alcohol such as methanol plus HBr. Nucleophilic substitution will take place and Br will replace OH. So the product will be CH3Br and H and OH will become H2O. So option 2 is also correct. 3. Passing the alcohol vapor over heated alumina. We can write the equation. We have ethanol, and when it is passed over heated alumina, which acts as a catalyst. Alkene is formed along with the removal of water. So option 3 is also correct. As all three options are correct, answer is therefore A. Question 40. The diagram shows part of the structure of polymer X. You can see the structure. In the structure you can see that we have ester functional group present. Which reagents react with the polymer X? Number 1, we have aqueous sulfuric acid. Now aqueous sulfuric acid causes acid hydrolysis of ester. And the reaction is reversible in nature. Option 2, aqueous sodium hydroxide. Aqueous sodium hydroxide causes alkaline hydrolysis of ester. And the reaction is non-reversible. Sodium does not have any effect on ester. The reaction of one part can be shown like this. We have CH3 upon reaction with water in the presence of acid, it will convert into this compound. Along with alcohol. Similarly, upon hydrolysis in the presence of alkali, the compound will react like this. Plus sodium hydroxide aqueous. The reaction will be in one direction. Product will be CH3. Along with methanol. As option 1 and 2 are correct, therefore answer is B.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.